Just start the session. I have taken question number first. Like the peak inverse voltage of diodes in a full bridge rectifier circuit is 230 volt. And what is the peak inverse voltage of diode in full rectifier in center type? Center type means it used a transformer 1:2 ratio, turn ratio. You know about the full bridge rectifier. Full bridge rectifier, the output is the pulsating DC, like a full bridge rectifier. Where V is the AC signal, like Vm sin omega t. I think everyone know about the waveform of full rectifier. I just want to show output becoming like that. Here is given Vm. Vm is a 230 volt. It is not the RMS value. This is a peak value because it is given as the diode peak in peak inverse voltage of a diode. Here is D1 and D2 diode on, and here is D3 and D4 on conducted. Here D3 and D4 is off. D3 and D4 is off. Period. When it is off, there appears inverse voltage. Then what is the inverse voltage appears by the diode D3? If Vs is supplied here, this was conducted. V3 is like VD3, and this terminal connected here. It means negative voltage appear on V3 as Vs, then VD3 is equal to minus Vs. Given in maximum voltage, peak inverse maximum voltage of Vs is Vm. Then you can say that Vt3 is minus Vm is the maximum voltage, but is given peak inverse voltage already given inverse. That means the positive value of Vm, like 230 volt in full bridge rectifier. The whole this one voltage appears on the D3, and also same appears on D4 because of this one is conducted like this. Then D4 also same thing, same voltage appears, D3 and D4. But in center type transformer, center type full bridge rectifier, bridge rectifier, use a transformer in such a way the output voltage is same and input voltage will be same. Then it was a two winding and loaded connected between them. That would be connected like that. This is supply here 1:2 ratio. Then this means this one divided into half is Vs. This one also Vs. Because of transformer user 1:2, it means it double the circuit voltage of Vs. The two Vs appear on the secondary winding, whole secondary winding, and Vs is separated from the loop. And this one I taken a V output, D1 and D2. D1 voltage means this one voltage VD1, and this one is VD2. Work in and output of form is the same like closed rectifier, but peak inverse voltage will change.
Yes, VD2 should be of opposite polarity.
What is?
The VD2 on the bottom,
Yeah.
that should be of, I think the right side should be positive.
This one positive.
For D2, sir, D2. Voltage across a diode D2.
No, I will taken both from the positive direction, but when
This is reference.
had a reference only.
Okay.
If you observe this one, the VD1 is positive, then it means diode will conducted. If VD1 is negative for ideal diode, this one is not conducted. Then a negative peak voltage is the peak inverse voltage. That's why I taken as a reference for them, the positive voltage.
Okay, sir.
We observe this when D1 is conducted. D1 in odd, it means this one short circuit, ideal diode I have taken. Then current flow like that in this loop. Then what is voltage of VD2? This one voltage. This one you have two loop. One loop like that regarding to V0. Second loop, another loop. You have this one also. You can apply KVL. If D1 is on, then V0 positive connected to the VS positive and V0 negative connected to the VS negative. It means V0 is VS. It also is VS. Then I apply first one this one loop. Then you can take KVL minus VD2 minus Vs. Then also minus V0 is equal to 0 in the loop. V0 also Vs minus VD2 is equal to 2 Vs. Then VD2 is equal to minus 2 Vs. Minus 2 Vs is not conducted in peak inverse voltage appears. And what is the maximum voltage appears when the Vs is maximum? I think Vm. So 2 Vm, the double of the bridge rectifier. The same thing if you apply this one loop, we find same equation, same value minus VD2 After that minus Vs, this one minus Vs. I will take an ideal diode. Then this one voltage drop is 0, and this one conducted. This means Vd1 also 0, and this one connected like that, equal to 0, and Vd2 equal to 2Vs same. Then is given the peak inverse voltage of diodes in a full wave rectifier 230 volt, and or just in center tap voltage is double of this one, I think 460 volt. The peak inverse voltage 2 into 230, 460 volt. You should require a double blocking voltage capability of a diode if you use a center tap transformer. But you use only 2 diodes. You have required only 2 diodes, and full bridge rectifier you have required a 4 diode. Question number second, I have taken like for a 3-phase 50 Hz 415 volt input supply, the output ripple frequency in 3-phase full wave rectifier. I think all of you know that this one, but I explain in such a way you understand what happened in 3-phase half rectifier and full wave rectifier. It is depending on the application. If you have application like a isolation type application, then you should use a center tap transformer. If it does not require isolation between input and output, then you can apply use the bridge also. And simple way is a bridge rectifier is more simple and not complicated. Simply you can use for diode and output is given, but in center tap you have designed a proper transformer. This one is much complicated to design a transformer. What is the turn ratio and what is the window factor, what is the permeability of core. This is an important thing to design a transformer. And it should bulky also, you become bulky. But where you require isolation, in that application you use the center tap transformer. You know about the diode property. If I have a 3 diode like that, and I have a load connected, you can say as a neutral, this one voltage VR, Vy, Vb, if this one anything voltage, I simply taken as a reference. Then whose diode is conducted when in this VR, Vy, Vb, which voltage is the maximum at a point, that diode will be conducted. It's right.
Yes, sir.
If this one is a 5 volt, this one 4 volt, this one 6 volt, it means diode D3 will conducted. All of the diode is off. And if you reverse this, if more than 10 volt, 2 volt, 5 volt, this one D1 is conducted. Same thing apply in the three-phase half-wave rectifier. In sinusoidal, if you apply sinusoidal signal, sinusoidal voltage to the 3 diode, you can, and this one anode and cathode configuration. Cathode is common. In this, the voltage apply to the anode, which is the maximum, the diode will be conducted. If same thing apply in opposite direction, like that, common anode configuration. VR, VY, VB. This one is at neutral. I have taken D1, D2, and D3. Then which one diode will be conducted? The diode, which voltage is minimum of all of three. Which diode is minimum, that diode will be conducted. Which voltage is minimum in this three. This one known as a common cathode configuration. This one cathode, this one anode, and this one is a common. Sorry, this one common anode configuration. This one common cathode configuration. In three-phase half rectifier, this type of configuration is used, but in three-phase full wave rectifier, we used both of configuration. Both are connected in series, and we observe both are connected like the one is a anode configuration, second one is a cathode common configuration.
Sir, here are VR, VB1, VBR. Are they phase voltages?
Yeah, phase voltage.
Okay.
First, I will take in this configuration to drive a half wave rectifier. I taken as a VR is a Vm sin omega t. You know about the Vm sin omega t minus 120 degree radius suspended three phase configuration sin omega t minus 240 degree. So NOR phase VR 120 degree collected. Take another line 30 degree, 60 degree, 120 degree, 30 degree, 60 degree, then 120 degree of this one. Then this one easy to draw. Three phase rectifier, three phase waveform. Some VB, some VY. Then what is the conduction of diode D1? D1 conducted when VR is maximum. Not VR is maximum from here to here. And all of voltages. Then here to here is conducted diode D1. D2 connected with the Vy maximum here to here, and diode D2 conducted, and remaining Vv connected to diode D3, Vv maximum here, and D3 conducted here. And what is the output? When D1 is conducted, it means output coming from D1 and VR, same voltage up here. After that Vy, this one is the output. Output ripple frequency, to observe this one, pi by 6 to 5 pi by 6, approximately 120 degree conduction. And frequency is the triple of the input frequency, because the input frequency is 50 hertz. Time period is 2 pi. To observe here time period, your whole is the time period of the input supply. You start from waveform here and end up here, and second waveform started from there here. And in the output ripple frequency, this one waveform started here, and this one complete one cycle. After the same waveform repeated two. That's why the time period is when the waveform is repeated to one. But that time is time period is 2 pi by 3. If we want to calculate voltage output, V output, same thing. Average output, find integrate of this one waveform, this waveform. You want to denote time period, and Vs d omega t, V naught for d omega t. This one is the waveform, that's why I use a small v. Capital V naught is average voltage. Time period is 120 degree, 2 pi by 3. Conducted where to here, pi by 6 to 5 pi by 6. Which one waveform? I have taken this one. It means this one is the sine waveform, starting from 0. Then this one is the Vm sine omega t into d omega t. To integrate this one, find cos omega t from pi by 6 to 5 pi by 6. 3 Vm upon 2 pi. If this one is negative, then put lower value first. Then we find cos pi by 6 minus cos 5 pi by 6. Cos pi by 6 is 2 pi by 3. Sorry, root 3 by 2, 60 degree. Oh, sorry. Yeah. 3 by 2. This one negative root 3 by 2. Negative positive. And this overall 3 root 3 by 2 pi Vm. Here Vm is a phase voltage. Here is applied a phase voltage Vm. It means this one is phase voltage. If you convert in the line voltage, then you can written like VML, the line voltage, divided by 2 pi is the output of a half wave rectifier. 3-phase half wave rectifier. Yes, someone on to ask something?
Cos pi by 6 is 0.5.
Cos pi by 6, cos 30 degrees, sin 30 is 0.5. Sin 30 is 0.5, 1 by 2. And cos 60 is 0.5. Cos
Okay,
30
sir.
is root 3 by 2. Same thing you can apply for the 3-phase full wave rectifier. In this 3-phase full wave rectifier, both configuration coming in the picture. When one waveform is minimum, then this one diode will on. When one waveform is maximum, then this one waveform will on. Like that, I show you 3-phase full wave rectifier. D1, D3, D5 is the positive, and D2, D6, and D4. You can take any configuration and you can change the V1 value, D3 value. What you want, you can change. Apply 3-phase. Take this one VR, Vy, and Vb configuration. I written here VR is equal to Vm sin omega t, Vy Vm sin omega t minus 120 degree, Vb Vm sin omega t minus 240 degree.
It should be VRY, right?
What? Sorry?
It is a line voltage, so VRY, VYP, and VBR.
No, I will take a simply phase voltage. VR, Vy, Vb is the phase voltage applied to the full wave rectifier. I've taken a 60, 120. Farm. So 0, so pi by 3, 2 pi by 3, so pi, 4 pi by 3, 5 pi by 3, and 2 pi. So R, this one Y, so VB, VY, and VR. When D1 is conducted, D1 conducted, VR is maximum. This one in all of thing. When VR is maximum, then VD1 is conducted, then the conducted here to here. This one D1 and D3 connected when VY maximum. Remaining D5. When D4 is conducted. D4 conducted when the VR is minimum to all of them. It means here to here only. Here to here D4 is conducted. And D6 connected to the VY, and VY is minimum, then D6 will conducted. Remain VB connected to the D2, and D2 is connected when VB minimum. So D2, the conduction will completed. And what is the output voltage? Output voltage, see, look at the part wise. Like this one, D1 and D2 conducted here to here. D1 and D6, right? D1 and D6, D1 and D6. D1 connected to VR, D6 connected to VY. Output voltage is VR minus VY, it means VRY. This one is VRY. After D1 and D2 will conducted, R and B, VRB. (60° VRB). Next one, D3 and D2 conducted, D3 Y and D2, it means YB, YB, same thing V,
YR.
Y, and R. Next one, D5 and D4, D5 connected VB, and D4 connected to Y, then VBR. VBY. So a three-phase output voltage. But the pulses, if you count this one, 1, 2, 3, 4, 5, or 6 pulses. The frequency is 6 times of the source frequency. If you want to calculate the output voltage, then you take any one of them and integrate time period. V output is 1 by T, T is 2, this one pi by 3 is the time period of one pulse, then this one pi by 3 integration. What is this one? This one is pi by 6, and this one pi by 6 to 60°, it 90 degree, pi by 6 to 90°, pi by 2. This waveform is VRY. VRY means VR minus VY. VR is Vm sin omega t minus Vm sin omega t minus 120°. This one VR, this one Vy. Integrates both one. 3 by pi. If you integrate this one, sin omega t, like will be cos omega t minus cos omega t. minus cos omega t will put value of pi by 6. First cos pi by 6 to pi by 2 minus minus plus, if you take a sine is cos omega t minus 120 degree pi by 6 to pi by 2. So solve this one, we find 3 root 3 Vm divided by pi. It will be 3 VML. Line voltage divided by pi is the output voltage of 3-phase full wave rectifier. The working is simple. So take a VRY is a phase voltage, and take the conduction of a diode. We have to add a conductor, diode first and diode second, like that. Mark them. After that, taken the output according to the diode conducting. So next question given, diode bridge rectifier capacitor filter circuit uses a resistor to limit the starting inverse current. What should be the minimum value of resistor in ohm? Consider the supply voltage regulated between 200 to 250 volt RMS. So 250 volt RMS. Diode have a maximum surge current rating is 100 ampere. A diode bridge rectifier capacitor filter circuit. You know about that. D1, D3, D2, D4. This one is Vs. Vs, we will know Vm sin omega t. Output voltage. So this one filter capacitor and filter voltage capacitor and filter resistor. So given the resistance of Rf should be minimum value of Rf to tolerate the maximum diode surge current rating. It should not more than the 100 ampere current in any condition of any diode. So current flow through any diode. You know about the capacitor in starting in initial condition, if capacitor is behave like a short circuit. If this one is short circuit, RF is not present, then huge amount of current flowing through the diode because the source is presented. And to limit the current, the series resistance is used to the filter, and is given what is the value of a resistance to limit the inverse current to 100 ampere.
Sir,
Yes,
is that resistor is in series with capacitor or is in series with source, sir?
you can use both.
Both away.
Yeah, same
Both
circuit.
are going to, yes.
Yeah, same circuit happen. If you use the here resistors or here resistor. If you use a here resistance, then the losses will be increased because of the it's a present any time, whole the time. If your source is on,
Huh.
and you can use here also, then limit the current. It's not much important, but you can replace this one. This is RC filter. If you replace this one from source side, then
If this
the
will reduce the source voltage, no, sir.
yeah.
Drop would be there.
You know about the form of output of this one is this on the source, and if a capacitor is charged some amount of voltage, and when this voltage greater than this one voltage, then so diode will be conducted like that, conduct here to here, peak value, and V output is like that. The remaining capacitor will on. This one waveform minus Vs conducted remaining time, then this waveform is coming in the picture, and this one is a capacitor discharge, and input current is like that when diode is conducted in this period only. So in the input current, if you want to remove this one, you can use here also to limit the current. Whereas if you use here, the losses will be reduced because of the source current conducting in very less amount of time, and when you use the filter resistance here with the capacitor will charge and discharge, the losses will be increased, and use here also to limit this one. Then diode will be conducted in this one, D1 D2, then Vs when the capacitor is the inverse current, capacitor will be discharged, behave like a short circuited at the initial point, and the maximum voltage appear, then I maximum is a Vm maximum divided by Rs. Maximum voltage is 250 is input RMS into root 2 divided by Rs you find, and I maximum is given 100 ampere, then 250 root 2 divided by 100, this one I think 3.53 ohm. You can use resistance to limit the inverse current. Inverse current means starting current. The starting inverse current, when switch is on, suddenly the capacitor at that time behave like a short circuit. All over is current flow like that. If a resistance is not present, then current will flow very high. It can damage the diode.
Sir,
Yeah.
if that current limiting resistor
Yes.
is in series with the capacitor, instead of connecting in series with the source, if it is connected in series with the capacitor,
Yeah.
then at that time the effective impedance, because two resistance are connected in parallel, then two impedances are connected in parallel, then the effective impedance will come down mostly.
Yeah.
So
This will also reduce the impedance. The current will be high.
okay.
And the losses will also increase if you connect resistance here. And capacitor charge and discharge and whole time resistance is present.
Entire 2.5 will be
Yeah.
connecting.
And when you connect to the
So it
source
is
side, then short of time only present. Losses will be there.
okay.
The following statement: the power supply uses a bridge rectifier. If one of the diode is defective, then the, then what happening? The statement is given like first one, second. The DC load voltage will be lower than this expected value. A ripple frequency will be lower than this expected value. Now, if one diode is defective, then whole bridge rectifier operate in half wave rectifier, that is a half wave rectifier. Then voltage and frequency both are reduced. Sorry, it's correct, not current. If I know about that. Vs and V output is like that. And one of the diode defect is when in the full rectifier current flow like that in positive half cycle, and negative half cycle current flow like that. So, but when you take a D4 is the defective. This one out picture, and this one is open circuit. And when the positive half cycle, then the current flow like that, the same as the healthy rectifier. This waveform will come in the picture. The output one, the second time taken as a D4 is defective. But when the negative half cycle is coming in the picture, then current will not flow because of this one high conducted. This one is not connected because of the this one is a positive value, this one voltage negative value, this is off diode because of the negative voltage apply here. And this one is the open circuit, then current will not flow. If current will not flow, I naught is 0, it means the voltage also 0. Then this waveform will come in the picture like same as a half wave rectifier. This is the output voltage and ripple frequency also reduced. Here the ripple frequency is twice of the source frequency. The its time period is pi. This one 2 pi, half of the source frequency. That is time period is pi, and this one time period is 2 pi because of the same waveform repeated here like that. And this one is the time period of this waveform 2 pi. If the time period is double, then frequency will be half, and both are correct. Zero power factor occurs when the load is purely resistive, purely capacitive, purely inductive, partially inductive, and partially capacitive. I think everyone is know about this question and this answer also. I want to just explain this one. I will take in the first one. It's like a resistive load. If AC signal applied to a resistor, and current flow like this one. Vs is Vm sin omega t. What is I? I same is Vm by R sin omega t. No any angle difference between the voltage and current, same as this vector waveform, voltage and current. Current will be lesser than the voltage supply because of the resistor is divided, and phi is the angle between the voltage and capacitor is 0, then cos phi is 1, power factor is 1 in the resistive load. This is not correct, 0 power factor is asking. Second, purely capacitive. This is AC voltage applied to a capacitor, pure capacitor. Vs is Vm sin omega t. I know in the capacitor current dVc by dt. Then this one you integrate this one, C differentiate, then this omega into Vm cos omega t, and I should be written like that, Vm into omega c cos omega t is, you can retain sin omega t plus 90 degree. It means current is leading voltage, this one is current, so 90 degree, phi is given 90 degree, then cos phi power factor, cos 90 degree is 0. 0 power factor occurs in purely capacitive and purely inductive load. Here one doubt, cos omega t can be written like a sin 90 minus omega t and sin 90 plus omega t, both are the cos omega t. But here is you can take a negative frequency, this one, so the negative frequency. If you want to replace this one, then you can take a sign outside, then you find sin omega t minus 90 degree, minus sin omega t minus 90 degree and omega t plus 90 degree. If you observe, this one is the same. I explain below. Second is the purely inductive load. Sorry. V is equal to Vm sin omega t, I is equal to V by L integration of minus Vm by omega L cos omega t Vm by omega L, you can return sin omega t minus 90 degree. It means this one voltage waveform and current waveform like that. So phi is 90 degree, then power factor is cos phi 90, 1 0, then power factor is 0 in both condition, purely capacitive and purely inductive. I written here, I show you 0 degree, 90 degree, minus 180 degree and plus 180 degree. Same, this one minus 90 degree. If we want to plot cos omega t, then cos omega t means if you taken this one as sine waveform, sine omega t like that, then angle is 0 degree. Sine, if you taken a cos omega t is 90 degree ahead from the sinusoidal signal, then this one is the 90 degree, this one is a cos omega t, or you can retain a sin omega t plus 90 degree, omega t plus 90 degree. But you can in the second observation, the minus sin omega t, after that minus 90 degree. If you go anti-clockwise, this one is positive angle. If you go clockwise direction, and this one is a negative angle count, and this one is minus 90 minus sign. First one take a minus sign. Minus sign means if you 1 and minus 1 is taken, then one is 0 degree, minus 1 is 180 degree, opposite of this one. So simply opposite of one each other. Then if you take the negative sign, it means the sign coming here, come here in this phase 180 degree. After this 90 degree, minus 90 degree means clockwise direction. If you move clockwise direction 90 degree, then you find the same point here plus 90 degree. You can return this one, and this one is the same quantity. You can return both are same, but here the frequency is negative. That's why you return omega t plus 90 degree. I will not return this one. Both are the angle configuration is the same. The voltage applied to the load, voltage is 230 volt cos omega t plus 20, and current down by the load is 100 cos omega t plus 5 cos omega t plus 2 cos omega t plus 4 cos 7 omega t and plus 4 cos 9 omega t. Find the power factor, average power, and the reactive power of this one. In this type of question, you take a fundamental, find the first one, fundamental where the frequency multiplied by multiplication of 1, then this one omega t, and this omega t is the fundamental frequency. After that, this one is the third harmonic, fifth harmonic, seventh harmonic, and ninth harmonic is present. If this type of question you are asking come, then you should find a power factor like average power of this one and to the VA and apparent power of this one. You divide by both, then find a power factor. VI cos phi. And normally you know this one cos phi is the average power, but you don't apply directly cos phi because of the a lot of harmonics also given. Then you should replace cos phi to power factor only. And can't say that the power factor is cos 20 degree directly. You can't say like that because of harmonics also present. The active power the real power is a fundamental component. It occurs where the fundamental component only, the voltage and current fundamental component to multiply of them and take in the cos phi is the angle, you can find the average power. But a reactive power you can't find like that to apply directly a sin phi because of harmonics is present. It means the reactive power will be increased. And reactive power increase, it means the power factor deteriorated. It's not same as the cos 20 degree, unlike the cos phi. Is some distortion factor occurs in the system. I want to explain in broad to find then why you take average power like only fundamental component. Why you can't add harmonics or other order in the fundamental in average power calculation. You know formula of average power, P average. Average of anything you can apply 0 to t integration time period Vi and dt. With t replaced by that angle, then you can measure d omega t like that. And voltage this one. I've taken 230 like Vm and 10 like I1 the fundamental. This one I've taken third harmonic I3. This one I've taken I5, I7 and taken is I9, ninth component, harmonious component. And P average is equal to 1 by T integration of 0 to T multiply by of thing, voltage and current. Voltage is Vm cos omega t plus 20, current is I1 cos omega t plus I3 cos 3 omega t plus I5 cos 5 omega t plus I7 cos 7 omega t plus I9 cos 9 omega t into d omega t. And P average 1 by T, same thing. Multiply by this one, Vm and this one. So find Vm and I1 omega t plus 20 degree into cos omega t plus Vm I3 cos omega t plus 20 degree into cos 3 omega t plus Vm I5 cos omega t plus 20 degree into cos 5 omega t plus Vm I7 cos omega t plus 20 degree into cos 7 omega t, and last one Vm I9 cos omega t plus 20 degree into cos 9 omega t. It's a long one, but don't worry. So use a simple formula in calculation, you can find it. This one cos A, cos B, same thing, all of them. Multiplication of cos, you can't integrate directly. Then apply 2 and multiply by 2, divide by 2, same, all of them. You can take 2 cos A cos B formula, divide by 2, find by 2, then you find 1 by 2t is a 2 denominator is common. Vm in all of part, then Vm also is the common. And this one cos omega t, you know about 2 cos A cos B is written as cos A plus B plus cos A minus B. Written this one, I 1 by 2t, 2 is common of denominator and Vm also common, 0 to t. Second first one cos A means this one omega t plus 20 plus B is omega t. Totally is cos 2 omega t plus 20 omega t plus 20 degree, and second one plus A minus B. This one minus this one, find cos 20 degree only. Next one cos omega t plus 20 degree plus cos 3 omega t. If you observe here, the cos find cos 4 omega t.
Multiply first term with I1, sir.
Yeah. Sorry. So now IN also present. Here I3 also present. I forget this one. Cos So we added 4 omega t plus 20 degree plus cos. If here is the cos omega t plus 20 degrees, when we subtract this one minus 3 omega t, you find minus 2 omega t plus 20 degree. Can we common omega t minus cos? You know about cos minus theta is equal to cos theta. Then you can common a minus here, then you find 2 omega t minus 20 degree in final equation. Now written directly 2 omega t minus 20 degree like that in all of things. Well, here cos 2 omega t minus 20 degree. Same thing is like I5 cos 4 omega t. This one is the 6 omega t plus 20 degree plus cos half of 4 omega t
minus 20.
4 omega t minus 20 degree plus I7 cos of 5 omega t plus 20 degree
8.
6 sorry 8 omega t 5 plus 8 omega t plus degree plus cos 6 omega t minus 20 degree plus I9 cos 10 omega t plus 20 degree plus cos 8 omega t minus 20 degree. Last one d omega t written by yourself. Vm by 2 pi 2t integration of 0 to t. Look here, what is the average quantity of the sinusoidal? You know everyone? I find average value na of everything is cos omega t or something is the average only. If you find a power, then this integrated is a sine or cos signal, and this one is a sinusoidal. If you want to find average power, it means you integrate you find the average sinusoidal waveform, a sinusoidal signal or cosine signal. This is a sinusoidal signal. Okay, cosine signal, if you shifted this one as 90 degree, then you find this one is this one sine signal, this one cosine signal. Integration means if 0 to t average value, it means integration of the waveform. If you integrate this one, you find the positive area is equal to the negative area. The average value of a sinusoidal is 0. And also if you want to calculate this one by yourself, sine omega t integration of 0 to 2 pi into d omega t, average value of a sinusoidal signal, then this one is a cos omega t minus cos omega t 0 to 2 pi. You can written as this one as a cos 0 minus cos 2 pi. Cos 0 value 1 minus cos 2 pi is 360, also 0 1. Average value of a sinusoidal and average value of cosine should always be 0. If you want to calculate cosine signal, cos omega t, same thing applied 0 to 1 time period 2 pi d omega t. Then you find sine omega t 0 to 2 pi sine 2 pi minus sine 0, sine 2 pi 0 minus 0 equal to 0. It means average value of sinusoidal waveform or cosinusoidal waveform will be always 0. It not depend on the lagging or leading factor. This one waveform is starting from 90 degree, so 90 degree leading. You can retain na cos omega t is equal to sin omega t plus 90 degree. Yeah, you can also integrate sin omega t plus 20 degree, sin omega t plus 30 degree. All of thing is 0 only because of the same waveform find. You can find same waveform, but delay or advanced signal you can find. Like this one, if you delay of high angle, then you find this one delay. Like that, same area is positive and negative. It means all of component is 0. Where is the frequency component is available? The picture in this one. 2 omega t plus 20 degree, you have integrate a time period, this will be 0. 4 omega t also here, 2 omega t, 6 omega t, 4 omega, 8 omega t, 6 omega t, this one, all of component is be 0. If you integrate one time period, for the one time period, all of component is 0, only this one will be coming in the picture. I leave this all of component and integrate only this one, because all of thing is 0, this one also 0. I show you to integrate this one as part this one, but this one you observe. Sorry. Understand everyone what I am saying? Like that. If you integrate a time period of sinusoidal cosinusoidal, the value will be 0 only. That's why I can't integrate all of things. All of them going to 0. Only this value is coming in the picture. That's why average power is Vi cos phi only. Average 1 pi t 0 to t I1 cos 2 omega t plus 20 degree plus cos 20 degree d omega t so they get 2 pi. So now you know coming to outside, this one is just minus sine 2 omega t plus 20 degree 0 to 2 pi.
So this cos 2 omega t will not be 0.
Why?
All second order frequencies are cos is becoming 0.
Average should be 0 na. So average will be 0 na. This one is the
Yeah, that
omega
can,
t. Omega
okay.
t. If you integrate this,
Yeah, I understood. Okay, sir.
this one also same one.
Yeah, same 0. We can take only that cos 20 term alone, no?
You can take cos 20 coming from here to here somewhere. Okay, this one like that. But average of a one time period, now you can integrate this one in one time period. Time period will be same now.
Okay.
If you integrate one time period, that's time will be 0. If you not integrate in one time period, then it will be not 0. I have taken one time period like the 0 to t, all of a signal in one time period. You get in one time period. That's why in one time period will be 0. This one cos 20 degree is a constant. Then this one is a t only. The omega t is a 2 pi. I written directly 0 to 2 is 2 pi. This one 0 and 2 pi sinusoidal is 0. Sin 20 minus sin 20 is 0. Plus 2 pi cos 20 degree. Then we find Vm I1 cos 2 pi. Cos 20 degree.
Cos 20.
Actually, missing something. This one 2 is common, this one 2t. I am missing this one 2t. Then you find Vm I1 is divided by 2. Then you can.
I was asking from the beginning itself, we can ignore that cos 2 omega t plus 20, as we know it is going to be 0. Why do you want to integrate and say it is 0?
Yeah, I taken this one up.
Okay.
Only for showing this.
Okay.
You know about the Vi cos phi coming the picture of all of the component will be 0. When you only compare 0, just so you know about the power, average power, Vi cos phi only. Then V is RMS value, I is RMS value, cos 20 degree. But this one is the average power, and it's active power. It's not not given in the reactive power information. You can't directly take in a Vi sin phi is reactive power when a component will be there. This is the average. Average power you can find Vi and fundamental RMS. I taken here. RMS of this one be 230 by root 2, and average power is 230 divided by root 2. Same thing like taken I1 10 divided by 2 cos 20 degree is the average power. So calculate this one, you can find 10 80 watt is the average power. And what the S VR RMS IRMS into cos phi total power, we calculated V RMS total power active IRMS total RMS means all of the component. This one the fundamental only, this one the all of component into power factor. You can't apply same one like cos phi. So power factor only. This is the same as the this one also is this one showing like active power, but compare of this one power factor will be different. That's why I've taken an average of fundamental and calculated average, and this one is the whole of calculating our power factor. Here the power factor just for the fundamental displacement factor, only for the 20 degrees. If you want to calculate this one power factor, then whole of you can find whole of RMS of this one. You know, to find RMS of I RMS total RMS, the integration of all of square divided by 2, 5 square divided by 2 plus 2 square divided by 2 plus 4 square divided by 2, 4 square divided by 2. Then if you calculate this one, you find 8.97 ampere something. You will find power factor 1080 is the plus fundamental divided by total. VRMS, IRMS, VRMS is 230 divided by root 2 into IRMS calculated the whole RMS, this one 8.97. Then if you calculate this one, find 0.74 is the power factor of this one. If you calculate this one only cos 20 degree, and cos 20 degree power factor is greater than the 0.75. I think 0.9 cos 20 degree approximately 0.93 something. It means the fundamental component delivered from the source, you can say that useful power is delivered from the source is on this one fundamental is work useful power, but in the whole component is also comparing to the taking the harmonics also. If you taking, then the whole power factor will be reduces due to the harmonics coming in the picture. If harmonics is not coming, then the both are power factor is the same. Same thing you apply for the converter. You can find the power factor Output power is equal to input power in ideal cases, same as formula, and the power factor taken the power factor, not only fundamental system. Same thing you can say like TSD. You know about TSD, distortion factor, total harmonic distortion. It's coming in the picture here. When harmonics present in the system, then TSD will be calculated. TSD is any quantity. If you calculate in current, then total current RMS square minus fundamental components RMS square divided by fundamental component of RMS into 100 in the percentage. This will shows the how much percentage of the useless quantity of this one. Useless power, you can say that if a TSD is the highest, it means the highest power is useless. You can't use this one power. But then you can reduce harmonics to use something like boost PFC. You know about the power factor improvement system to improve the TSD. In further you learn about the thyristor control rectifier. That time you calculated the RMS, TSD. Then you find for single phase control rectifier TSD is 48%, approximately 8.3%, and 3 phase is 31%. If you use the 3 phase control rectifier, the TSD will reduce, and it means your used power is more in 3 phase full control rectifier with respect to the single phase control rectifier. And distortion function power factor, total power factor is normal power factor. You know about the distortion factor. If harmonics is present, and distortion factor into fundamental displacement factor. This fundamental displacement factor means the fundamental displacement between the current and voltage. In the previous question, you seen like a fundamental displacement factor is a cos phi 1. Cos phi 1 into is a comparing the fundamental only. Then phi 1 is given like a 20 degree, and this one is the 20 degree. Fundamental displacement factor. If harmonics is present, then distortion factor will be also coming the picture. And distortion factor you calculate like that, then what is the, it means what is the fundamental component over the whole component. It means I1 RMS to total RMS. This is defined the distortion factor. What percentage of the distortion occurs in the system? This will be decided. In previous question, if you want to solve and find the fundamental RMS and total RMS, I think total RMS I will find like 8.97 ampere. If you want to fundamental RMS, want to find fundamental RMS 10 by root 2 7.07 ampere. Then what is the G? G is fundamental to total RMS. 7.07 divided by 8.97 0.788.
Yes.
Then what is the power factor? Power factor is G into cos phi 1. This one is the power factor, and where is the harmonics present. You can apply this one, all of thing. G is 0. Distortion factor 0.8 watt, 8, and cos 20 degree. Cos 20 degree is 0.9 something. Overall power factor find 0.74.
Sir,
Yeah.
if both voltage and current are having harmonics, then how to find this G, sir?
Then you can find a G1 like voltage and current also. You can replace this one HD. You can find voltage HD are different and current is HD different.
No, sir,
Then
this distortion factor.
this
If,
distortion measure, in that condition you only distortion factor to if fundamental of this one voltage and fundamental of current is find second harmonics in both condition, then both are useful power, not analysis power. This one useless, not a useless power. If a fundamental is sorry, second and third harmonics also present in the voltage, that will produce the power to the load.
okay.
This is not a distortion field. This will distort only for where the voltage, your voltage is the only fundamental component, but current have some harmonics. In that time you can find the distortion. But where when the voltage and current both are the same harmonic component, that means there is no distortion.
So distortion factor is 1 at that time.
Like that, this one, like a DC value, if you take a voltage waveform like this, square wave,
Okay.
and current waveform same as square wave. In this waveform, you know about the this one all of harmonics present in all of third harmonic and multiplication of third.
Yes, sir. It is always
This one.
all are useful power.
So it means all is useful power because of same harmonics present in voltage and current also.
Yes, sir. At that time, distortion factor will be 1.
Yeah.
And then the fundamental displacement, the second part will be
This
same.
one, if this one there is some displacement in current, then you can find the power factor like that. Distortion factor occurs where the TSD occurs when the waveform is different. Like if
No, sir.
if you have
The fundamental distortion factor. Sorry, the second one, fundamental displacement factor.
yeah.
Anyway, if both voltage and current are having harmonics, the distortion factor will be 1. Then the fundamental displacement factor, the second part will be whether it will be the same, that is a phase angle between fundamental voltage and fundamental current.
This one is same, na. If one current have some displacement, then all of current have some displacement.
Okay. Okay.
If you have like I1 something for V I naught, you can read and further I something, but n pi sine n omega t plus phi. Okay. Then n multiply with the whole of system, na. N omega t is 2 omega t, then multiplication of this one also. This that type of system. Then phi is the same for all of them.
For all component of voltage and current, it will be same.
If you take a fundamental, then the one phi.
So similarly, other harmonics voltage and the corresponding current will also have the same phi.
Yeah.
Thank you, sir.
This one, if you have sinusoidal is the output, and if you taken this one is the current, this type of current. In that condition, you should find the distortion. This one is Vs, this one Is, and this one is the fundamental displacement factor. You can't say this one is the power factor, cos phi.
Yeah.
In that condition, phi is the displacement factor, fundamental displacement factor.
Okay.
Yeah. If this one is the same as like that, sorry. In this condition, the fundamental component will like that.
Yes.
This one is the fundamental I1 sin omega t. You compare this one to this one signal. You can't compare to some different signal to one signal. like weighted and liter, like the kg and liter you can't compare, na.
Yes.
So that's a signal also here. You can't compare to sinusoidal to square wave. You want to compare the sinusoidal to square wave, you should have a you make the square wave as a sinusoidal in form of sinusoidal, like a Fourier series expression. You know about it. Fourier
Yes, sir.
series expression. You explain the square wave in a Fourier series expression. In that condition, you compare the two signal, two same signal, like sine and
Yeah, when both the voltage and current are having same order of harmonics, then the distortion factor will be 1.
yeah. So the next question given, like a half-wave rectifier is given and a battery is connected in the output to charge the battery. Then what is the conduction angle of the diode? You want to charge a battery from the source Vs is like a Vm sin omega t. And what is the conduction time of a diode? Then when will be conducted? This is the half-wave rectifier, that's why I've taken. So omega t 0, pi, 2 pi and 3 pi. This one Vs and is given V, the total is V naught, R is the battery resistance, taken V naught is a whole of thing, and V naught 50 volt is the battery voltage, like this one. So battery voltage is 50 volt. Vs is the maximum, Vm here. Then diode will be conducted when Vs is greater than the battery voltage, when this voltage is greater than this one voltage. So an anode, this one cathode, Va should be greater than Vk. It means Vs greater than Vb. Vs is Vm sin omega t should be greater than 50 volt. Greater than or equal to, you can say, in this angle is here, the diode will start to conduct and stop is here. It will be stop and remaining is off period. After that, in this next cycle, in this period it will conduct and then remaining in the off period. And this one is V output which I will take in a whole of resistance and the battery, then battery also come in the picture. Then this one battery voltage appears, and when the diode will be on, then this type charge the battery like that. This one is the same as this one, only this time period is diode will be conducted. And what will the value of this angle and this angle? You can find
This 30 and 1.
Vm sin omega t is equal to maximum is equal to 50 degree. Then omega t sin inverse 50 divided by 100. 100 is the Vm is given. Then this one is sin 1 by 2,
30 degrees.
30 degree. And after 30 degrees, diode will start to conduct, and remaining 30 degree here also. Then you take a conduction time in a degree. If you find in degree, then omega t is equal to 180 degree minus some conduction time start ending minus started minus 60. 120 degree. 120 degree is the conduction type of the diode.
30 degree far. Then 150.
Yeah, this one is 150 degree and this one is the 30 degree, and conduction time between them 150 to 30 degree. If the same is if same configuration happen, if you use the full wave rectifier, then this one is the coming the picture also on one pulse, then frequency will be double. This one half wave rectifier. This one is a full wave rectifier with a, you can say with a RE load, resistive like a battery load as battery. Then what will be the output voltage? You can use the same formula to integrate this one. This one time period. Time period is the same as 2 pi. If you want to calculate V output, one time period V output into dt. So given in omega t, then take 1 by 2 pi equal 0 to 2 pi Vs minus Vb into d omega t V is Vm sin omega t minus Vb d omega t. This one signal present only for 30 degree to 150 degree. You say pi by 6 to 5 pi by 6 Vm sin omega t into d omega t minus remaining is the battery voltage present 0 to 5 pi by 6 to 2 pi. This one is the one, the constant is outside to d omega t. Here to here voltage is present only, battery voltage is present. The 150 degree to, and this one also present, that's why I have taken 2 pi total.
150 to 2 pi.
No, sorry, 2 pi plus 5 by 6. No.
We are starting.
So this one 2 pi, 150 to start it, and this one 2 pi plus 30 degrees more. 5 by 6 to 5 pi by 6 to 2 pi plus 5 by 6.
So it has to be up to 2 pi.
So the time period is different. This one time period, if you taken this one here to here time period, that's why I've taken like that. This one pi by 6. Then this whole of signal available pi by 6 to 2 pi plus pi by 6. Can you understand? Whole of this one is the 2 pi only. Time period is the 2 pi by 2 pi plus pi by 6 minus pi by 6. The 2 pi time period. You can take it 0 to 2 pi or pi by 6 to 2 pi plus pi by 6. You take a 0 to 2 pi here to here, or you can take a here to here also na. This one pi by 6 to 5 pi by 6 and 5 by 6 to pi plus pi by 6. That's why I taken pi by 6 to pi by 6 is sinus model available signal. After that battery available. Total time period 2 pi. Vm cos omega t pi by 6 to pi by 6 minus Vb 2 pi. Cos pi by 6 root 3 by 2, so minus to 3 by 2, 3 by positive 2 pi to Vb. This one is the average output voltage of RE of half rectifier in RE load. Same thing occurs when full wave conduction. This one is 2 pi. And replace the 2 pi to pi, here also pi. Understand how I am taken pi by 6 to 2 pi by pi plus t plus pi by 6. The time
Yes, sir.
period is same. You can take here to here also. Okay, I am stopping here. And thanks to all.
Sir.
Yeah.